Hi folks, so in this video what we're going to do is a question here based on the topic of solids in contact, and in this question what we're going to be doing is working around three solids. Okay, so what we have here is the elevation and plan of two solids. We've got a cylinder A, and we've got a cone B that is sitting slightly in front of the cylinder as well. And here's the information. Okay, so it says here, the figure over shows the elevation and plan of a cylinder A, which is this guy here, which has a height of 85, and then when we look at the plan, it has a diameter of 90, which means that the radius is 45. Okay, and it's in contact with a cone B. The cone B has an altitude of 70, and then down here in plan you can see that its diameter is 76, which means that its radius is going to be 38. So part A, it says draw the plan and elevation of the solids. So that's what we're going to start with. So over here roughly on the XY line, I'm going to start off by drawing the elevation. I'm just going to pull this down a little bit. Okay, so starting over here, I'm going to start off by making a rectangle. This line here, from here to here, is going to be 90 long and it's going to be 85 high. So I'm going to start off with my rectangle here. I'm going to make it 90 in length, from there to there, and mark the middle as well, which is 45. Okay, so having done that now, I'm going to do a vertical line and a vertical line, and I'm going to mark up a height of 85. Now that I've marked up the height, that is my rectangle for the cylinder. I'm also going to mark in the center line, which is usually with a long, short, long, short, long. That's kind of how you'd mark the center line. And what I need to do now is draw in the circle in plan that we would see when we're looking down the top of the cylinder. Okay, so from there, I'm just going to do a line down. That's my center line. I will take the radius from here. So that's going to be my radius there. And all I'm going to do is going to come down far enough that I know it's not going to hit the XY line. I'll move it up a little bit. Go a little bit higher, about there. And I'm going to draw in my circle. So there we have it. There is our elevation of the cylinder and our plan view of the cylinder. Now what I always do in the plan then is I'm going to mark in my axis lines left and right like that. Okay, so now that we have that done, what I'm going to do is I'm going to heavy in a little portion of the cylinder that I know I can heavy in. I'm just going to just use my marker here to heavy in some bits of information. Okay, and as you can see, the cone is going to be slightly in front of it, so I'm just going to draw this a little bit down there, like that. Okay, in the plan I'm not going to heavy it in just yet. Now what we have to do is we have to get the cone in contact with the cylinder. Now where a cone will touch the cylinder when they're both sitting on the ground is actually at the base. As you can see over here, that is going to be where their point of contact is. Because of the nature of the solids, they're not going to overlap, so the cone and the cylinder will touch on the ground. So how do we draw that? Well, from the center point you can see there's an angle of 60 degrees here, but if you use a bit of maths, okay, the angle that's left inside there is 30. So all we want to do is, from the center point of the circle, okay, in plan, or the cylinder I should say, I'm going to go out at 30 degrees. I'll move this down a little bit now, just so we can see it a little bit better. I'm going to go out at 30 degrees, and then I'm going to measure out the radius, okay, so diameter 76, which means that the radius is going to be 38. So from this point here, which will end up being the point of contact, that point, literally right there, that's where they're going to end up touching. I'm going to measure a distance of 38 millimeters. Now that I've done that, I'm going to take my compass and I'm going to draw in my cone in the plan view. So there's the cone in the plan view. Now that I've got the cone in the plan, I'm now going to draw it up in the elevation. And once again, I'm going to draw in my lines left and right going through the center. So, from the center point of the cone, I'm going to do a line up. The overall height of it, if you remember up here, is 70. So the altitude is 70. It's going to mark up the height, so from 10 up as far as 17, just to have the apex marked. So right up there, that's my apex. And now what I want to do is I want to find the outside or the extreme generators. So from, let's say, 3 o'clock and 9 o'clock, I'm going to go up vertical. And there we have it. That there is our cone. Now we have our cone in contact with our cylinder. And what they always say in these questions is always to find points of contact. So the point of contact of where the cone and the cylinder actually is right here at that point. So I can find that one in the plan. How do I find it in elevation? Well, in the elevation it's going to be on the ground, so I bring it up, and that's where the point of contact will be in elevation, POC. Now, the next part of this question, it tells us, okay, and this is the challenging part in this question. So we've done that part over here, this part is done. I'll come down here now and just might have to zoom out a little bit. There we go. So it tells us here then, a sphere of diameter 60 millimeters. So a sphere of diameter 60 millimeters rests on the horizontal plane in position S. And we can see here, position S is there. Okay, so they're saying they want the sphere in this position here. Position S. Okay, and what it is, it's resting on the horizontal plane. That means it's touching the XY line, the ground. So what we want to do, so that it is in contact with the cylinder A, so it touches the cylinder, and it also touches the cone B. So it's touching both of them, both the cylinder and the cone. So I'm going to have a sphere in here that is in contact with both of them. Determine the plan and elevation of this sphere. So, rule of thumb here is, what we have to do is we have to get a ghost sphere on either side of the cylinder, and then another ghost sphere on either side of the cone, and then rotate them around until they're in contact at the same position that's going to be equidistant away from both. So, I'm going to start with the cylinder, that's the easiest one. Okay, so what I'm going to do, it tells us information about the sphere. The sphere has a diameter of 60, which means that the radius is 30. So from the XY line, I'm going to measure up 30 millimeters. So from the 5 there, I'm going to mark up 30, which will bring me as far as 80. So the center point has to be somewhere along that height, 30 millimeters above the XY line. That's step 1. Okay, and it's going to be the same at the other side, so I'll just do the line across. The center has to be somewhere along that line, 30 millimeters above the XY line. Now, for the sphere touching the cylinder, all you do is you measure out from the side of the cylinder, measure out 30, and if you want, I'm going to put it in ever so lightly here. This is what's called using a ghost sphere, because really all I need is the center. There's no need for me to draw this, but I'll just put it in lightly. We can see it there. That there is going to act like our ghost sphere. Okay, it's the sphere when it's in position directly at the side of it. So if I was to draw that in plan, the center point would come down, and that would be right there, the center point of my sphere, the ghost sphere, once again when it is at the side of it. I'll draw it in once again, just for demonstration purposes. It's not needed, but I'll just put it in ever so lightly. Okay, once again that is the ghost sphere. Now, what I'm going to do next is I'm going to get the ghost sphere when it's at the side of the cone. So how do we do that? Well, first of all, what we're going to do is we're going to bisect the angle between the extreme generator and the XY line. So I take my compass, and I'm going to bisect that angle there. Make it a little bit bigger. Okay, now that I've got that bisected, anywhere along that bisector will be any circle that will touch both the XY line and the extreme generator of the cone, which is the outside edge. But I want the one that's exactly at a height of 30. So where that bisector passes through the 30 millimeter height line, that there is now my center of a ghost sphere. So let's draw it in. Actually, just draw the line in vertically first, so I have my radius again, because that's where it's going to touch the ground down there. Now I'm going to take my compass. I'm going to mark that, and all I'm going to do is draw it in ever so lightly. Once again, just drawing it in lightly to start off with. This once again is my ghost sphere. It is the correct sphere, but not in the correct position just yet. But all I wanted with that was to find where the center point was. I didn't actually have to draw it in. So now what I'm going to do is I'm going to bring that down to the plan and locate the center point down in plan. Okay, once again, I'll just draw it in, just for demonstration purposes. Once again, this is the position when it's at the side. Now, We've done a lot of work to get to this point. Once again, it's quite a large question, so I'm just going to zoom in a little bit, or zoom out a little bit, sorry. So this is the position of the sphere that has a radius of 30, diameter 60 when it's in contact with the cylinder at the side. We have another sphere of the same size that is in contact with the cone. Okay? And what we want to do is we want to move those, okay, any of these spheres into position S, okay, so that it's both going to be in contact with the cylinder and the cone. Okay? So this is how we do it. What we're going to do is we're going to rotate their centers about, because as this one rotates around the cone, okay, the center point will always stay the same distance away from the center point of the cone. So I'm going to rotate the center. Now unfortunately I have to put in the page a little bit low down. I'm going to rotate that, take my time. Might go off the page slightly. You can see there, apologies. So somewhere along that arc there is the center point for the sphere. Now what I need to do is rotate the sphere that's in contact with the cylinder. And when I rotate that one around, where the two arcs intersect, that is the exact center point of a sphere that is both touching the cylinder and the cone. Okay, now just really quickly, I'm just going to get another quick piece of paper there. Apologies. To do with my own setup, should have set it up a little bit larger. Just going to stick that down. That can happen times in the question. Just set that down there. Excuse me. So just redo that arc so it shows on the page. There we go. Okay, so you can see the arcs there. Now that is the exact center, as I said, that touches both the cylinder and the cone. So now I'm going to take the radius 30, just take it from over here because I have it already drawn. I'm going to take that radius 30, and there we go. I'm going to draw in my sphere. And that is the sphere in the correct position. Now that I've done that, I'm going to start using my other compass to start heavying in information. Okay, because I can actually heavy in everything in the plan now. And then we'll get up to the elevation. So in the plan, I can actually fully heavy in the cylinder. Okay, I can actually fully heavy in the sphere. And I can heavy in the cone, however not fully. So I'll heavy in that much. Just have to adjust that slightly, sorry. There we go. Now, the sphere slightly overlaps the cone. So inside there, we will have hidden detail. Okay, so that's my plan view completed, and you can see how I used the two ghost spheres rotated around until they came into a position that is touching both of the other solids. Now that I've done that, I need to find the position of the sphere in elevation. So the center point is here in plan. How do I find it in elevation? Bring it straight up, and we know the center point has to be at exactly a 30mm height. So right there, that is my center. So once again, I'm going to draw that in. And just take the radius from here. And this guy here is actually going to be in front, so I can draw this guy in fully, I think. Ooh, nearly slips. Absolutely made a hames of that there now. There we go. So there is our sphere in elevation. Now, in regards to heavying in the other information, I can heavy this, but the edge here at the side of the cylinder is all going to go in as hidden detail the whole way down. The cone, I'm going to heavy it as far as there, but then that will go in as hidden detail. Down here there will be a little bit visible, and then out here. And there you have it. That is what the elevation looks like. That is what the plan looks like. Now for a junior cert topic, that's probably as hard as it'll kind of get. The last thing you're always going to be asked at the end of the question, we already found one of them, you're going to have to locate the points of contact between all three solids. And in this case, because we have three solids, you'll have 3 points of contact, but 3 in the plan and 3 in the elevation, so maybe 6 altogether. We found the one where the cylinder was touching the cone, here in plan, here in elevation. The next one we're going to find is where the cylinder touches the sphere. It's the easiest one, and we'll get on to then the cone and the sphere. So in plan I can see that quite clearly. All I do is I join the centre of the sphere to the centre of the cylinder with a line. When you connect the centres, technically that proves where the point of contact is right there. How do I find that in elevation? So all I'm going to do in elevation is bring that up, and that is my point of contact then here in elevation. The point of contact in elevation when a sphere touches the cylinder is always going to be at the height of the centre point. Okay, if you imagine this is where the point of contact was when it was at the side, so it has to stay at the same height. So now we've got 4 of them, 2 in elevation and 2 in plan. Last one we want to find is where the point of contact between the sphere and the cone is. Now for that one, we do need to come back here to our ghost sphere. So what we're going to do is we go perpendicular to the extreme generator from the centre point of the ghost sphere. So using our set squares like this, I'm going to take my 45-degree set square, put the number side on it, I'm going to slide it across until it gets to the opposite side, and now I've gone perpendicular to the extreme generator. I've found the point of contact when it is at the side of it. Now that's not the one I want, that's when it's at the side, but we will have to rotate it. So what do? I'm going to bring that down to my plan. That's where it will be when they are touching at the sides, but that's not the position I want it. I want it over here somewhere, and where it's always going to be is where the centres join to each other. Okay, so I'll join the 2 centres, and how do I find it then? All I do is I rotate my point of contact around, like we rotated the centre. So rotate the point of contact. You can see there, I've rotated it from here, rotate it around until it hits there. There is my point of contact between the cone and the sphere. Now that I've found it in the plan, I need to find it in the elevation. So I found it in the plan, I bring it up. It's somewhere up along that line. How do I find the exact height of it? Well, this was the height when it was at the side, so that will also just go across. And there we have it. Right there, that's my point of contact. So as you can see there guys, that there is a challenging enough question, okay, where we have 3 solids in contact. We had a cylinder in contact with a cone, and then we had to get a sphere that was touching both of them as well. Okay, quite a challenging question, a lot of information there. Hope you found it helpful. That's the question done.